Okay, so the question we're trying to answer is, what is light? One theory is that light behaves like a particle. That is, light is transmitted as packets of energy called protons. An experiment that verifies this claim is the experiment where you shine different colored lasers through fluorescent liquid. When you shine in red light, you would see the red light go straight through, and in the middle you would see kind of like a grainy image of the beam of red light. This shows that the red light is reflecting or bouncing off of the particles in the liquid. And so the light must be the particles itself, because the particles are bouncing off the particles. And there is no color change. Whereas in purple light, when it goes through, it does not go through. But when it's in the liquid, it makes the liquid glow a brighter color. This is because the particles in the liquid have absorbed energy from the purple light. Absorb energy from the purple light, which is in discrete packages, and causing their electrons to get excited and raising them to an energy level. When they release that energy, light is released, and so you get a glow. However, if light was what suggests that the energy is in discrete packets is the fact that when you leave red light for a long time, the liquid does not begin to glow. Because if the energy is continually being transmitted, it'll eventually start to glow. But then it doesn't suggest that it's just one particle interacting with one particle one at a time. So because the red light does not have enough energy, no matter how long you leave it there, it's not going to glow.
Now we see that light can act as particles, but it can also act as waves. So first of all, in white light, you have all of the colors of the spectrum. They're all present, and each color has a different wavelength, and varying them gives different colors. For instance, if you look at the red wavelength, it is of course much bigger because it's at the start of the spectrum. But if you look at violet light, their wavelengths are much shorter. And when this happens, the shorter wavelength ones have different energy, which is why if you look at the same experiment as before, the one with the fluorescent, the highlight of liquid, that's why if it was a wave, which it might be, but it might not be. But the thing is, it's always disputed as to whether it's a wave or not, or a particle, and none of us can tell. You see, they could be particles, but they act like waves. But they're also waves that act like particles, so they might be able to vary themselves or not. So it's been disputed. So they might be either or they might be neither. So they might be the same thing, or they might not be anything at all. Thank you.